This is Ramanujan's formula number 1 of 1914. 1 by pi is equal to root of 8 divided by 99 square multiplied by sigma 0 to n equal to 0 to infinity. 4n factorial divided by 4 to the power of n factorial whole to the power of 4 multiplied by 1103 plus 26390 into n divided by 99 to the power of 4 into n. Let us call these two inside the sigma as A and this is B. So we want to calculate when n equal to 0, when n equal to 1, 2, 3, 4, 5. First let us substitute n equal to 0 in this formula, n equal to 0. And here I have already done that. Here it is 1103 plus, sorry, this is 4n factorial. So A is being calculated here. And if you look at the formula, I can see that A is factorial 4 into n. So this symbol is fact, F-A-C-T. And inside the bracket, it is 4 into n. And n is at D39. That is 0 here. And that is divided by the whole to the power of 4. So I am putting power of what? 4 power n. I can either use this symbol, add symbol, or I can put power. Outside, I put power symbol. And inside I get 4 to the power of D39. D39 is nothing but 0 into factorial of D39. So that completes A. B is here. B is here. It is factorial. This is B. 1103 plus 26390 into n. N is at B39. Divided by power 4n power 4 into D39 of what? 99. Power syntax is power. Suppose I want to say power a to the power of b, I have to say power bracket open a comma b. That is a power b. So that calculates a, it calculates b, then it is a into b. So this will be F39 into D39. Now if I drag the formula to the next few lines up to 5, now this will be taking for n equal to 1. So you get D40. This takes for n equal to 2, n is 3, and 4, and 5, and same thing. And when it is written 1.62675 e to the power of 10 to the power of minus 35. This is 10 to the power of minus 27. This is 10 to the power of minus 20. 10 to the power of minus 12. And this also here like 10 to the power of minus 5. 2.6832 into 10 to the power of minus 5. That means it's divided by 10 to the power of 5. 10 to the power of 5 is 1 lakh. So 2.6832 divided by 1 lakh. Now we have to calculate what is the summation. We are only doing up to 5. We are not able to do up to infinity. So we have to add these things. So this is the sum of A into B. Now we got outside the summation, we got square root of 8 by the 99 square. So here we are multiplying this number. So we have got square root of 8 divided by 99 to the power of 2 into whatever is there in H45 is this number. Now that will give us 1 by pi. Get pi, we have to take 1 by of this one. We have to take a reciprocal of whatever we have got here. So it is 1 by what is there in H46. So this is equal to pi. And if I use, now this one is nothing but, you can see that it is pi. Bracket open, bracket close, it gives the value of pi as stored in Excel. And you can see that it is up to this. If you go beyond this, it is giving 0 because Excel is not storing anything beyond that. It's all coming 0, 0, 0 only. It is actually not 0 here, but Excel doesn't know. Excel is only up to, and when you're using up to 5, even this formula also calculating up to, not beyond that. Now, if I take 5 instead of 5, if I take 6, it might give me some other number. I will not know whether it is correct or not, because here Excel gives only, but of course the internet you can get up to 35 places also. Currently, pi is known up to 3 trillion decimal places. So this is another method of calculating pi using Ramanujan's second equation. We are here done Ramanujan's first equation. So any of these two will come for the examination. So prepare for both. So one batch will get this formula. And if you're lucky, you'll get a simpler formula for the second batch, depending upon whether you are in batch number 1 or batch number 2. That is based on first come, first serve basis, because the number of machines are not enough for all 40 to take 45 plus to take examination in one go. Another one is we have done square root of 2 earlier. So square root of 2 earlier using Bodhan's formula as given in his book Sulabha Sutras 2800 years ago. For square root of 3, we are going to use a different method, and that is called Madhava series. Madhava was an Indian mathematician of Kerala. It is called Madhava of Sangrama Grama, 1350 to 1425. This equation was rediscovered by Leibniz and Newton. And that became the basis for calculus much later, but this was at least 200 years, 300 years earlier to that. So using this equation, sine theta equal to theta minus theta cube by 3 factorial plus theta to the power of 5 by 5 factorial minus, so plus and minus alternating, and in sigma notation it is sigma minus 1 to the power of k by 2k plus 1 factorial. So when n is k is equal to 0, it is because minus 1 to the power of 0, that is plus 1, and 2k is 2 into 0, that is 0, 1 factorial, so it is 1, theta to the power of 2k plus 1, 2k is 0, so theta power, so that this is first one. This is the second one when n is equal, k is equal to 1. This is when k is equal to 2, because every time it is 2k plus 1. 2k plus 1. You don't have to remember all those things. We'll just take this equation, and I have written this equation for, and I'm taking theta is equal to 60 degree, and 60 degree sine theta, we know it is root 3 by 2. So root 3 by 2 is obtained by this entire thing. So on the left side, I got root 3 by 2. Root 3 by 2. So theta is 60 degree, and the value to be put in that equation is not in degrees, it is called radians. And theta degree 60 degrees equal to nothing but pi by 3 radians. So pi, we know it is given in Excel, divided by 3 comes 1.04, because pi is equal to 3.14, etc. We have seen it earlier. So this is pi by 3. So this is theta here. The first part of the equation is, I can bring it here. I'll copy from here and I'll bring it maybe here. Theta is here. This is theta cube by 3 factorial. Theta cube by 3 factorial, you can see. Where is theta? Theta is in this B3. So theta is here B3 divided by factorial 3. Now I have put dollar sign here so that when I drag from here to here, it doesn't change, because theta is only in one place. And only thing that changes here, denominator becomes 5 factorial. Here denominator becomes 7 factorial. Here denominator becomes 9 factorial. Denominator 11 factorial. Denominator 13 factorial. Calculated up to 3, 5, 7, 9, 11. Then you're taking summation of that. So here, summation with the, what I mean to say is, it's not a sum. Summation means its minus sign is also there. So I'm taking this minus this plus this minus this plus this minus this plus this. It's written here. A6 minus B6 plus C6 minus D6 plus C6 minus F6 plus G6. And that comes to root 3 by 2 because sine 60 degrees is equal to root 3 by 2. So to get root 3, you have to multiply by 2. So this becomes root 3. That is the value obtained by using Madhava series. Now in Excel, I can calculate using the root of 3 is the formula. And that comes to up to 175. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So up to 10 decimal places, it is coming correct. Now, if I use instead of 13, I can go to 15 and 16, 17 and 19, etc. It will become more and more okay because this is up to infinity. I've only taken up to 5. So part of the class, one batch will get root 2 for calculation, another batch will root 2 is easier. Root 3, you require this. So practice both of them and get the value of root 3 using Madhava series and value of root 2 using Bodhayana Sulabha Sutras and pi using Ramanujan formula 1 and Ramanujan formula 2. Is all a question of practice. Watching 100 times is not going to help you. Doing it once is good enough. All the best. Thank you.